Well, Computer Architecture Lecture 7, and today we will study microarchitecture. This class is divided into two videos. In the first video, part 1, we will study about the microarchitecture basics, where we will study the component of the microarchitecture. As you know, microprocessor is a sequential circuit, so it must have to have a memory element and the combinational circuit part. So we will study these two, and in the second video we will study about the single cycle data part, and we will also introduce the virtual classwork in the second video. So let's start with the part 1, microarchitecture basics, while we study the memory and the combinational circuit part. Well, what is microarchitecture? So typically it's a connection between logic and the architecture that specifies the arithmetic logic unit, memory, and registers. So in this course we will define the microarchitecture for a particular ISA, which is MIPS ISA. In the past 6 classes, we extensively studied the MIPS assembly language, and here we will also work with the same ISA, I mean MIPS, with microarchitecture. So MIPS or any other ISA may have different types of microarchitecture that having some trade-offs, like some could be targeting low cost, some could be targeting high performance, and also there is a part of the complexity. So this is the trade-offs that keep in mind to determine the microarchitecture. So in this class we will study the classification, and particularly we will study single cycle architecture, and later on, next classes we will study multi-cycle and pipeline. So before we start this, let's try to introduce what are these. So in single cycle processor, what you can say, you know the instruction, right? So each instruction executes in a single cycle. So it's pretty simple. In a single cycle architecture, each instruction executes in a single cycle. So every clock cycle you execute one instructions. So the definition says what will be the multi-cycle. Yes, so in multi-cycle architecture, each instruction is broken up to series of shortened steps, and it executes only one instruction at a time, but each instruction takes multiple clock cycles. This is why it's called the multi-cycle. So one instruction needs multiple cycles. And the third one is pipeline. This is most common to the real world, and it can be execute several instructions simultaneously. So you have a concurrent execution. So we will study pipeline and multi-cycle later on. Today we will focus on the single cycle. That means instruction execute in a single cycle. So before going to the single cycle instruction, I would let you introduce about the architectural state. Our MIPS processor consists of the program counter PC, and we have 32 registers. All the 32 registers we have studied in our assembly program part. Well, and on top of that, we will study the following instruction to understand the microarchitecture. So in the early classes, we have studied many of the instructions, but to make it simple, in this part, so we will study the following instruction. The first one, in register type instruction, we will study some basic addition, subtraction, or SLT. After that, we will instruction in case of the memory operation, the load, store, and we also try to study branch instruction. So in early classes, while we are studying MIPS assembly language, on top of this we have studied extensively almost all of the complicated instruction. But to understand microarchitecture, I think these are quite enough, because we are studying the microarchitecture, not the assembly language itself. Okay. Well, so microarchitecture again have two interconnecting parts. Most importantly, before studying the microarchitecture, you need to know very well these two things. The first one is data path. So the data path contains the structure, okay, so that have in memory, register, arithmetic logic unit, multiplexer, etc. And the control unit is the key to control everything inside the architecture. So the control unit receives the current instruction from the data path. So it receives the instruction from the data path and tells the data path how to execute the instruction. Well, that means, so there are memories, register, ALUs, multiplexers. So the control unit tells the memory when it needs to enable read or write. It tells the ALU when it needs some arithmetic operation. It tells the multiplexer what input should be selected. It tells the register set when to be enabled and everything. Perhaps control unit control the operation of the data path. Well, again, sequential circuit. As all of you know, the microprocessor is a sequential circuit. And the basic definition of a sequential circuit being the input and output is depend only the present state of input as well as the previous state. And as you know, you must, in every sequential circuit, you must have to have a memory element to store the previous output. Well, so it's been detailed in every clock cycle. So if you consider from the raising edge of a cycle to these and these are a combinational part. So within this period, one thing is executed by the combinational part. Well, and then the memory element. That means here, that is store the memory operation, and the next raising is execute the same thing by the combinational circuit, having the memory input and the current input to find the output. So this is the sequence from here, it's come from here, and then restore the memory. In the next cycle, it goes here, it comes from the input, and we'll got the output. So this every time, in every cycle, it changes the value of the memory element. It comes from here and overwrite the memory, and then goes to here to execute the combinational part for the next state. So with the time, in every clock, it's doing the same thing repeatedly. And this is the behavior of sequential circuit, perhaps the behavior of microprocessor. So let's introduce with this memory element and combinational circuit for a small example. One of the good example of the memory element is the flip-flop we have studied last classes, that can store the input to the output. And another example of combinational part like a multiplexer. So using select line, it determines which input goes to the output. Well, so these two things, I mean the memory and the combinational circuit, makes the sequential circuit, and it operates looks like that. So in our study, we are talking about the instruction per cycle. So each instruction execute in a single cycle. Here, this is a cycle. This part is one cycle, right? Whatever the instruction is. So, for example, load word instruction need to be executed by one cycle, right? So, and then after memory operation, another combinational part be done by the next. So the instruction, every cycle we need to execute on instruction, and then in the between we have the memory part. So in these classes we will extensively look up with the load word instruction. Okay, and let's start with that. So as we talk, we have two parts, the data path and the contour. Okay. So we need to study that things extensively for every instruction. For example, we pick the instruction, that means load word instruction. Okay, so the instruction looks like this: load word, temporary register 2, the offset 20, and then the shift register 0. That means we need to load the memory address 32 because this register contains 0. So basically this is the base address, and these are the offset that we studied earlier. So I don't go detail, and this is the register. If you make this instruction as a 32-bit MIPS binary, you will get this number, this value. Okay, this is the offset, and this is the immediate part with the instruction, and this is the number of register T2, and this is the number of register 0, and these are the opcode for the load word. So throughout this class we will analyze this instruction with the data path and the contour lines, how the different building blocks of the microarchitecture are handled this instruction. So once you are able to understand this instruction, gradually we will move to other instruction like register type and other. Well, so in the next video we will introduce with the microarchitecture component in terms of memory device and combinational part. Okay, so this is end of this video, and let's move to the next video to introduce the microarchitecture component. Thank you.